Hey guys! Today we're going to be looking at the physical properties of organic compounds. We're going to have a look at what these properties are and how we can explain them. Let's start off by looking at some physical properties. First, melting point and boiling point. Melting point being the temperature at which a solid turns into a liquid, and boiling point being the temperature that a liquid turns into a gas. Next up, from this, we could get the phase at room temperature. That being, is it a solid, a liquid, or a gas? The next property we're going to look at is viscosity. This is the resistance of a liquid to flow. So if we think of water, if I were to pour water out of a bottle, it's going to flow quite easily. If I were to pour oil, it's not going to flow as easily. And if I had a bottle of syrup and I try to pour it, it's not really going to flow that easily at all. So what we'd say is that syrup is very viscous. Two other properties that are quite related are volatility and vapor pressure. So volatility is how easily a compound will evaporate, and vapor pressure is the pressure that the vapor phase will exert on the surface of a liquid. So if a compound is very volatile, there will be a lot of molecules in the vapor phase, and as a result there will be a higher vapor pressure. So why is it that compounds have different physical properties? Why is it that syrup is more viscous than water? Why is it that some organic compounds are liquid and some are gas at room temperature? So the one thing we can use to explain all physical properties of organic compounds is intermolecular forces. So let's recap. What are intermolecular forces? Intermolecular forces are the forces that exist between molecules. For example, if I had these two water molecules, so let's consider these two water molecules. The intermolecular forces are the forces that exist between the two molecules over here. These shouldn't be confused with the intramolecular forces, which are the forces that exist within a molecule, such as the bond between the oxygen and the hydrogen. So just remember, intramolecular forces are within a molecule. These are the bonds in a molecule. But the intermolecular forces are the forces that exist between molecules. So, if a compound has stronger intermolecular forces, this means that there are stronger interactions between the molecules, and as a result, more energy will be required to overcome these interactions. So let's keep this in mind. Okay, so what are the factors that affect the strength of intermolecular forces? Well, there are two. Firstly, the size of a molecule, and two, the polarity of a molecule. Let's start by looking at the size of a molecule. More importantly, what we're actually concerned with is the surface area of a molecule. So let's imagine these two blobs are two molecules. We have a smaller one and a larger one. The smaller molecule has sites all around it that it can interact with other molecules. But the larger molecule has way more sites that it can interact with other molecules. Another way we can think of this is like Velcro. If I have two small pieces of Velcro, it's quite easy to put them together and pull them apart. If I had two larger pieces of Velcro, it's going to be a lot harder to pull them apart. And let's imagine we had a person in a Velcro suit jumping onto a Velcro wall. That's going to require even more energy to pull them apart. So we can use this idea to explain how the surface area affects intermolecular forces. That being, your surface area is directly proportional to the strength of the intermolecular forces. Let's have a look at this example. Which of these two molecules is going to have a higher boiling point? So we have ethane, which has 2 carbons, and propane, which has 3 carbons. We can see that ethane will have a smaller surface area than propane. So remember, larger molecules have more points of contact. Therefore, they can form stronger intermolecular forces. As a result, they are going to require more energy to break these intermolecular forces, and therefore having a higher boiling point. So which of these two will have the higher boiling point? It will be propane. I want you to take note of the way I answer this question, as this is how you can answer questions relating to the physical properties. These are usually for about 3 or 4 marks in your exam paper, and so you can just put the 3 or 4 bullet points that explain your answer. So if we have a look at this graph, we can see that as the number of carbons increase in a molecule, the boiling point will increase. That being, if there are more carbons in a molecule, the surface area is going to be larger. So let's look at these two now. Pentane and 2,2-dimethylpropane. Well, they both have 5 carbons, but pentane is a linear molecule, so it's stretched out, whereas 2,2-dimethylpropane is a branched molecule, so it's scrunched up. Let's think of a piece of paper. A flat piece of paper has a larger surface area than a crumpled up piece of paper. So, branched molecules will have less points of contact, therefore having weaker intermolecular forces, requiring less strength to break these interactions, having a lower boiling point. So if a branched molecule has a lower boiling point, then the molecule with a higher boiling point is going to be pentane. Okay, now we've had a look at how the size affects the intermolecular forces, that being a longer chain, stronger intermolecular forces, and branched chains will have weaker intermolecular forces. Take note, we usually use the size of molecule to explain the relative strength of intermolecular forces within a homologous series. Now let's have a look at how polarity affects the strength of intermolecular forces. Let's recap. We can have nonpolar molecules and polar molecules. Nonpolar molecules are only going to experience weak London dispersion forces, whereas polar molecules can experience dipole-dipole forces as well as hydrogen bonding. Let's remember that hydrogen bonding is the strongest intermolecular force, and this is stronger than dipole-dipole forces. But dipole-dipole forces are stronger than London forces. So the relative strength of these intermolecular forces, hydrogen bonding is the strongest, and London dispersion forces are the weakest. So how does polarity relate to intermolecular forces? Well, the strength of polarity is directly proportional to the strength of the intermolecular forces. So let's have a look at this. We have ethane and chloroethane. Which of the two is going to be more volatile? Well, they both have 2 carbons, and neither of them are branched, so we can't use the size of the molecule to explain this. So we have to use polarity. If we look at ethane, we can see that it is nonpolar. However, chloroethane is polar because of the chlorine, therefore resulting in a net dipole moment. So this is a polar molecule. Polar molecules are going to experience dipole-dipole interactions, and nonpolar molecules are only going to experience weak London dispersion forces. Therefore, your polar molecules have stronger intermolecular forces. That meaning they are harder to separate. As a result, they are going to be less volatile. So which one of these is more volatile? It will be the nonpolar molecule, which is ethane. So now let's look at these two. Which one is going to have a higher vapor pressure? We again have chloroethane and ethanol, both having 2 carbons. So we know from the previous example that chloroethane is polar. And then we should be able to see that ethanol is also polar. But the main difference between these two is that ethanol has this OH, so it can form hydrogen bonds. Remember, hydrogen bonds are the strongest of the intermolecular forces. So let's remember, hydrogen bonds are stronger than dipole-dipole forces. Therefore, if a molecule experiences hydrogen bonding, it will have stronger intermolecular forces. As a result, it will be less volatile, therefore having a lower vapor pressure. So which of these two has the higher vapor pressure? Well, it's going to be chloroethane. All right, which of these two is going to have a higher boiling point? So ethanol and ethanoic acid, both 2 carbons. Ethanol will experience hydrogen bonding, as will ethanoic acid. But ethanoic acid can experience hydrogen bonding at 2 sites. So it will form more hydrogen bonds. So if there are more hydrogen bonds, this means there will be stronger intermolecular forces. This means it will require more energy to overcome these interactions, resulting in a higher boiling point. So which of these two has a higher boiling point? It's going to be ethanoic acid. So let's remember that polarity is usually used to explain the trends in intermolecular forces when we are comparing 2 different homologous series. Let's summarize. When we're comparing 2 compounds, we need to determine which of those compounds will experience stronger intermolecular forces. And we're going to do that by looking at the size of the molecules and the polarity of the molecules. If a molecule has stronger intermolecular forces, it is going to have a higher melting point and higher boiling point, and it's going to have a lower volatility and a lower vapor pressure. I hope this has helped you understand the physical properties of organic compounds a little more, and let's just remember the one thing we can use to explain the physical properties of organic compounds is intermolecular forces.